Let us learn an important property about circles. This is a very interesting property also, and it has far-reaching applications in our circle geometry. So we have a circle here for this purpose, and we have its center at O, right? The center is O. Now consider any 2 points on the circle, say P and Q. Now PQ forms an arc of a circle, right? So PQ is an arc of a circle. We just learnt in at Math Decoded here that the arc, any arc of a circle subtends an angle at the center. So if I just join the endpoints of the arc P and Q, my line is not straight. So I'm just joining the endpoints, right? P and Q. This is subtending an angle here at the center. The angle at the center is angle POQ. Now, the same arc PQ can also subtend an angle at any point on the circumference of the circle, isn't it? No one is going to stop them from subtending an arc at the circumference. So, let me join this same endpoint P. Let me use dotted lines because my lines are not so straight. So, this is also not straight. Fine. So, let me join P to the circumference, and from the same point let me try to join Q. Yeah. So I have a triangle here, and this is A. I have an angle subtended here at the circumference by the arc of the circle, PQ. So now in this video, let us compare the angles POQ and angle PAQ and find if there is any relationship between these two angles. Why are we finding? Because they are after all subtended by the same arc. So we should look for any relationships. Let us just explore. For this purpose, let me just join OA, the two vertices of these angles. Once again, my line. Yeah, let me use blue color and join the two vertices. Oh my God. So let me go from here. Somewhat, yes. So I've joined OA, and now what are we going to do? We are going to compare if there is any relationship between this PAQ and this POQ. So what do we know about these two triangles which are formed? Two triangles are formed, isn't it? One is triangle POA. POA, center is O, center of the circle. The other is triangle QOA, right? Okay. So fine. These two are radii of the circle. OA and OP are radii of the circle, so they are equal to one another. So we are looking at an isosceles triangle with two sides equal. Two sides of the triangle equal means the two opposite angles are also equal. Okay, let me mark these two angles in black. So these two angles are equal to one another, right? And what else? Similarly, in this triangle QOA, once again you can say that these two are radii, OA and OQ. So if they are radii, then the opposite angle, same explanation. The isosceles triangle, two sides are equal, hence the two opposite angles are equal. So this is what we have now in these two triangles. Now since the black is equal to black and the red is equal to red in these two triangles, let us use the angle sum property of triangles and find out the angle around O. This is what we are interested in now, right? The angle around O. Of course, the full angle would be 360 degrees. But what about this angle now? If I'll use a different color, maybe a gray color. What about this angle? This would be equal to 180 minus 2 black. Sorry, this is black. 2 black. So this angle is 180 minus 2 black. Which angle? The gray angle. The gray one would be equal to 180 minus 2 black. And let me use the white color here. So what is the white one equal to? The white one would be equal to 180 minus 2 red, right? 2 red. Fine. So I have around O, I now know two angles. One is 180 minus 2 black, one is 180 minus 2 red. So what is the angle which we require, which we are looking for? Angle POQ. So what would be angle POQ? It would be equal to 360 minus all of this. When I add these two, I can write it here. So what do I get when I add these two? I get 360 minus, let me take 2 as common, it would be equal to black plus red, right? Or POQ would be, I have to rewrite the same thing here. Instead, let me just subtract this from 360 and write it. Angle POQ would be equal to, angle POQ would be equal to 360 minus this whole thing, right, which would be equal to 2 into, yeah, I think we are arriving at something, black plus red, right? This is angle POQ, 2 into black plus red. I think it's too colorful. I hope if you look at the video slowly, you'll be able to follow. But this is not the formal proof. This is just an intuition. If you arrive at this, if you understand this, well and good. Anyway, we'll be doing a formal proof quickly now. So now we know that POQ is 2 black plus red. And why is this interesting? This is interesting because what is PAQ? My God, what is PAQ? It's already black plus red. So we have a relationship now. POQ is the bigger angle and it is equal to 2 times PAQ, right? So look at the relationship. So can we say the angle subtended by an arc at the center is twice that of the angle subtended by the same arc at the circumference of the circle. Now off to the formal proof, because without the formal proof, writing an exam is also difficult, right? So let me now, we have the same figure here. PQ subtends an angle at the center and an angle at the circumference. Now let me join OA, right? So what did we see there? We saw that OA is equal to OP. So let me write, in triangle OAP, we have OA is equal to OP. Hence, we have these two angles equal, right? Hence, we have, shall I write, yeah, angle OAP is equal to angle OPA, right? This is one. Now, let me change the color. Look at the triangle OAQ. Here also, you have OA is equal to OQ, radii of the circle. We discussed everything. So the opposite two angles, isosceles triangle, so two angles are equal. OAQ is equal to angle OQA, right? So we have 1 and 2. Now again using angle sum property. So let me use the gray color here and here. So what is this angle? This gray angle would be, or let me write angles now. After this, you have angle POA is equal to 180 minus 2 times these two angles, OAP plus OPA, or I can even write 2 times angle OAP, because both are equal. Both are equal. So I am replacing OPA by OAP. So 2 times OAP. And what about my angle QOA? Angle QOA is equal to 180 minus 2 times angle OAQ, right? And why am I writing OAP and OAQ? Because I am also interested in this angle. No, that is why I am writing these two angles. Fine. So I have this. And now, summing up everything, this whole gray angle would be equal to 360 minus 2 into OAP plus OAQ, right? Or would be equal to 360 minus 2 times angle PAQ, right? So now we are interested in this angle. what is POQ? So what is POQ? POQ would be equal to 360 minus this whole thing, which is, let me just copy it, to 2 into angle PAQ, or this is equal to 360 minus 360 is 0, minus into minus, plus 2 times angle PAQ. And so we have a relationship now between POQ and PAQ. The angle subtended by an arc at the center is twice that of the angle subtended by the same arc at the circumference of the circle. So the proof was, though difficult, we by our intuition we are able to prove it, and we've done the proof formally also. But there can be different cases of the same figure. The point at the circumference may be here, or it may be here, or it may be here. So we'll explore all the cases in our further videos. Thank you.